It was about dynamical systems, but from the point of view of game theory. So actually, the name was Dynamic Games, and it's I think it's very interesting. You know, games is a mathematical model of conflict or bargaining between individuals or governments or firms and so on. So there are a lot of interesting problems in this area. And I think it's very nice, you know, game theory, because it's in the middle of a very theoretical subject. You need a lot of stochastic processes, functional analysis, and so on. But at the same time, it has a lot of applications in biology, in economics, in engineering, even in money laundering. There are examples, you know, of game theory. So it's a very nice combination between theory and applications. Yeah. Well, as I was saying, it's a very nice subject because it combines all this kind of mathematics. You know, not only the applications, but also you need a lot of optimization, real analysis, probability, all kinds of techniques. You know, so it's I would say that it's for mathematical students. You know, students in mathematics. I think it's a very formative subject. You know, you can learn a lot of things, and or you can go to applications, or computational problems are also very difficult. Game theory in the dynamic sense, as opposed to static game theory, it has a lot of open problems. So I mean, even if you look at you know, a typical elementary book on game theory, which is usually static game theory, almost every 2-3 pages you're going to find a problem that is open in the dynamical case. So it's very attractive. You know, it's very nice. Well, actually, it's I think it was an accident. When I was very young, I went to the army. So I was in the Mexican Air Force College in a place very close to Guadalajara, Zapopan, yeah, in the municipio of Zapopan. And I went there, but I realized that I didn't like the military life, you know. So I decided to, as soon as possible, to leave the army and study some professional career. So my idea was to study aeronautical engineering, yeah? And in those days, and I think even now in those days, it was the unique school in all Mexico, the Instituto Politécnico Nacional, that has this career. So I went there to, when I graduated at the Air Force College, I tried to get a position in another Air Force base, but in Mexico City, very close to Mexico City. It's between the Mexico and Pachuca. And so I stayed there 4 years, and I went to the Politécnico in the afternoon, in the evening schools, you know, in the evening. And so I wanted to study engineering, but then I met someone that talked to me, no, you go better to physics, it's more interesting, and so on. So I went to physics, yeah? And I began physics, and then I was in a I was a 5th semester or something like that. There was a problem at the Politécnico. It was closed, you know, so in a strike, no, una huelga. So I was in the military, but we were in a strike. You know, it was a little complicated, you know. So a friend of mine said, you know, why don't you read this book? It was an algebra book, you know, and I was surprised, you know, that this. In algebra, group theory, these kind of things, you know, modules and so on, you begin with just a small set of objects, and then you assign an operation, and then you start playing with these things, you know, and you end up with a huge theory, you know. I was really amazed, you know. It's very interesting. So it was in those days when I decided to go back. I mean, instead of going back to physics, you know, when the school reopened, I went to mathematics. I make the change, and that's how I ended up doing in mathematics. I think it's doing very well, you know. But the problem is that It's growing. For example, I was at the SNI in around 2000. I was in one of these commissions, dictaminadora, and we were less than 300 members in mathematics, in the mathematics section. And now the director of CONACYT said this morning, in his lecture, that right now we are over 600 mathematicians in the Area 1, right? So I think it's very interesting. You double the number of mathematicians in about 10 years or 11 years. I mean, it's growing very fast. The problem is that it's not that there's no planification. It's like growth because population is growing, or students see a lot of TV or something like that. But there are no specific plans to promote the learning of sciences and these kind of things. So so again, going back to your questions, I think we are doing well, but we could do a lot better if there were more plans, events like the MCA or the what's the name of the Mexican Mathematical Society or the Academia Mexicana de Ciencias and so on. If they had more active programs, to promote this sciences in general, Yeah. So we're doing well, but we could do better.